The rain is coming down, the cloud is low. Time for another day in the workshop. The design idea is to build this car cheaply and quickly using parts from wreckers or parts that I have already lying around from previous builds. I've tried to follow the advice of Pat Clarke, one-time Formula student judge and now advisor to FSAE teams around the world. He has a lot to say about building light and building cheap and building simple. Free online site vsusp.com was great for figuring out geometry and dimensions. Pat Clarke says not to fret too much about roll center and other complications. Put the lower control arm in flat, the upper control arm tilted downwards, and the complicated geometries will look after themselves. And while I've followed Pat Clarke's advice closely on the front, I have McPherson struts on the rear, and I've tilted the lower control arm up just slightly to help with camber gain. The result is camber gain that's more or less the same front and rear, despite the McPherson struts on the rear, and at about half the rate of roll. So if it rolls to a maximum of, say, 3 degrees, the camber is then gains 1.5 degrees, which is all within the range of negative camber when it's set at static. Pat Clarke would say, look after your tyres. Don't have them pattering and bumping and jumping all over the place so they lose traction. In my case, I have 1 millimetre track width gain on the front at full bump, and I have about 5 millimetres track width gain on the rear at full bump. Now, what all of these settings mean in practice, I don't know. I'm probably not a good enough driver to tell a difference or exploit it in reality. I want to replace the rubber bush in the front suspension arm with something more substantial to stop the front suspension moving around under heavy cornering and braking. It's only the lower suspension arm which has currently got a rubber bushing in it. The rubber bushing has a lot of flex. The top suspension arm runs on needle bearings, so in fact it's got no flex in it whatsoever. I'm going to make the bushing out of acetal and put in stainless steel bushes. I could have used Delrin, but Delrin is about 3 times the price of acetal with only slightly better mechanical properties, and is really just not worth the money for what I'm trying to achieve here. I'm also only going to put the hard acetal bush in one end, and at the other end, well, initially leave the rubber, but ultimately replace it with a hard polyurethane bush. The reason I'm only doing one end is, first of all, this end is more highly loaded on the front suspension than that end. And secondly, if I do 2 bushes in very hard acetal, then I'm going to have trouble with the alignment of both, because I just don't trust that I can make the bushings exactly correct, and nor can I line bore them. Now, if the hard bushes are out of alignment, they're just going to naturally bind and transfer all sorts of horrible warping and twisting and other loads into the steel itself, which I don't want. So a softer, albeit still quite hard, polyurethane bushing here is going to allow some misalignment and absorb the misalignment in the system. That's the plan. Let's get making. The first thing to do, which is very high on the crappy tasks I don't like doing list, is to push the rubber bushing out. Right, straight to plan C. It appears to be my lucky day. I've got a socket that just fits over the rubber insert, and I'm actually having some success in forcing it out using the bench vise. It's a little bit more pressing to go. Done. No fires, no black smoke, no annoyed neighbours. This was made easier because the MGF arms do not have an outer sleeve on the rubber bush. Just need to clean the inside up a bit where it got scratched. Alright, that will do as 2 mating faces. The tube that's been polished, which is this one here, has a noticeably shinier surface, which I think will pay dividends in reducing wear inside the bush. Right, the action now turns to how I mount the front suspension. I've got the rough or close dimensions from using the software program vSUSP, which gives me an idea of suspension geometry and where the heights of the wishbones go. Mounting into that point is relatively straightforward. You can see I've just got a gusseted mount there, and to here also relatively straightforward, although I do have to build a gusset to really reinforce this area. The challenge then is how I put the top arm in, because I'm mounting to angles that go off in different directions, and I think I'll need to build a flat plate first, because this is also where I'm going to move sideways to set caster and in and out to set camber. camber is set by putting a packer in between the suspension, between the top arm carrier and the chassis. Right now I've got negative 3.8 degrees camber, but by adding packers I can actually take that through to any number which is greater, even positive if I go crazy. Caster is set because there's movement in the top arm that I can lock in, and that's between positive 4.4 degrees and positive 7.6 degrees caster, which is probably a fairly handy range. This is the pull rod. It has left and right hand threads so that the length can be adjusted by twisting the centre. It has threaded bungs welded around the outside, but also there's a split in the tube and it's welded through that area as well to strengthen it. Similarly at the other end, except in this case there is a high tensile bolt with the head turned down to be a tight fit in here, and then similarly welded along the sides and at the ends, and then I've just put a opened up nut on the end so that I've got purchase to turn the centre. Pretty straightforward, made two. Now let's fit them. I'll just jury rig it initially with some low tensile crack bolts, and then when all the motions are correct I'll come back in and put in proper fastenings. Right, that looks like I bought one. And now the left side is in place. I've set the pull rods to their shortest length, which means I have to set them at full droop and then make sure the rising rate starts at full droop. Right now the rising rate is too steep at ride height. A little bit of fiddling about to do will get this right. I've also got good adjustability on the pull rod, but I think the reality is once it's set I won't need to adjust it. Okay, we're at about a 90-degree bell crank angle at full droop, and I've still got the threads on the pull rod with 1.5 times their diameter engaged. So this is about where we want to be. I'll move the suspension through its full degree of motion so that you can see the progressive action of the bell crank. Right now the wheel and suspension are at full droop. It goes minus 30 mil to plus 30 mil in its range of motion. The pull rod is at about 90 degrees to the bell crank, so the the pull rod can exert its maximum leverage over the torsion spring. But as it goes up, the whole assembly straightens out. We're now well beyond full bump. With it straighter, the pull rod loses its mechanical advantage, its leverage advantage over the torsion spring, and so the spring rate effectively goes up. Down to full droop, that's about ride height, and then up and beyond full bump. And I'll return it to normal ride height. Neat, huh? The front suspension is now more or less complete. The pull rods are in place, the bell crank is in place, the dampers are more or less there. They're just jury-rigged in there with clamps and bolts. The whole vehicle is sitting approximately at ride height. I'm quite pleased with the result. I've got good adjustability for camber and for caster. And once I get the car on its wheels, I'll be able to move this torsion leaf pack in and out and get it mounted so that I can adjust the spring rate and pretension preload appropriately. The dampers are adjustable in compression, so that's another area of adjustability that I'm bound to get wrong in practice. So that's the front almost done, and I'll sign off at the front at this point. It still needs to be completely seam welded in place, but I'll save that when I'm really comfortable with the setup, and also when I set up the preload and spring lengths on the torsion springs. However, I'll park that for a moment because I'm now moving to the rear suspension, and I won't make any of these vital adjustments till the car is actually sitting on its wheels and I can see how it's affected by its weight and general stance. That's it.